Not the LeetCode LeetCode 286 walls and gates. This question is about binary search or DFS search. The first, we can use brute force to solve. This is a 2D array matrix. There's walls and gates and infinity rooms. We need to find the shortest path from each room, empty room, to the nearest gate. So the brute force will be from each empty room to go to the nearest gate. This will be exceed the time because the time will be mn is the matrix row and columns. Then in each row and columns we need to find the shortest path, which will also cost m times n. So the total time complexity will be m squared times n squared. The space complexity will be m times n, since this will be we need to store the matrix for the queue's size. I use BFS to solve this problem. First, this is the brute force. There's empty, gate, and wall. Empty will be infinite integer. Gate is 0, wall is -1. And then directions is left, right, up, down. But actually here is something wrong. Here it need to be, this is left, this is right, this is up, this is down. In the wall and the gate, if the room length is 0, we return. If row equals the room's length, column equals the room first list length is the column. Then we do the for loop, and based on distance gate function, we can see the nearest path. In the nearest path, we do, if the queue is not empty, we pull the latest point from the queue. Then the queue row is the point 0, the column is point 1. Then in each direction, we calculate row and column. When we need to calculate is based on if row is smaller than 0, column smaller than 0, or row is bigger than row, or column is larger than columns, or the room is equals to wall, or the distance is not 0, we need to continue. This means if the empty room is wall, or empty room is not empty, means it's limited, or the empty room exceeds the boundary, we need to continue to search. If it is empty room, we can calculate. So we can calculate distance is row point, column point plus 1. The distance is this one. Distance is this one. Distance is the new row in the column. This one. So if rooms RC, row and column equals gate, we return the distance and we input to the queue. And if it is not, we cannot find the shortest path, we return the max value. So we keep the infinity number. So what's the difference with the BFS? We don't need wall here actually, since we are searching from the gate. So this will decrease the time complexity. The gate here, we go left, down, or right, or up to see the 4 directions. So in this case, everything is very similar like brute force, but we don't need a wall here, and this is a simple way to write the left, right, and up and down directions. Here is also same, but we don't need distance gate for another function. We just need a while loop here. So we create a queue again, and we loop through it. If the room equals gate, we do the calculation. We put the gate into the queue, and if the queue is not empty, we go to the 4 directions. And same as here, if the 4 directions is not empty, so if this is out of the boundary, or the room is not empty, means it can be wall or gate or visited, so we continue to search. So if it is empty, we +1 to get the value. Then we put into the queue. The time complexity and the space complexity will be the same as OMN, since we only do the for loop here, and for the while loop, we only do the direction, 4 directions for each of them. And the space complexity, we only create the queue here to store the space.